Hello everyone, my name is Mike and I want to introduce you to my channel called Build It or Buy It. I'm hoping you're here to learn about building a trailer from scratch, which is exactly what I'll be doing in the next several episodes. However, first, I wanted to touch on what you can expect from my channel given it's new. Overall, it'll focus on fabricating or modifying various different things versus buying them, hence the channel name, Build It or Buy It. Over the years, I've regularly found myself saying, I can build that, or that's a poor design, I can improve it, and in many cases that's exactly what I've done. So I decided that there are likely lots of you out there that have said the same things to yourself. So I decided to create this channel in hopes that it will inspire and help some of you to indeed build something instead of buying it. And the trailer is my first project that will be on the channel. If you do find my content interesting, please support my channel by subscribing and liking. So now on to why you're probably here. How to fabricate a trailer. First off, the regulations and laws regarding home-built trailers likely varies from state to state. So what I'm doing may or may not be okay in your state. So please take the time to do the necessary research to find out what you can and can't do in your particular state. In my state, the Department of Licensing and the State Patrol regulate home-built trailers. You can fabricate a trailer for use on the roadway, but you are required to provide documentation for all the materials you use to build the trailer. Then after the fabrication is complete, the trailer needs to be inspected before the State Patrol will assign a VIN number and initiate a title. In regards to trailers, generally there are dozens of types of trailers. There's a good chance you may be thinking about a trailer design that is different than what I'll be building. Don't let that discourage you from taking on this type of project, as the methods and techniques I'll use can be applied to many different types of trailers or, frankly, many different types of projects. The trailer I'll be building is a drop axle. It'll be a bumper pole versus a gooseneck. It'll have a 10,400 pound gross vehicle weight rating. Overall length is going to be 20 feet. The last 3 feet of that will be a dovetail design with folding ramps that are incorporated. So you should see a pop-up here on the screen, and this will give you a close approximation of what I'll be building. This is not the exact trailer, but it'll be similar to this. I'm going to make some improvements and add a few extra things. So you might be asking yourself, how does one go about designing something like a trailer? Well, there's lots of different things you could do, but frankly the simplest way is to look and see what's out there at various dealers and mimic what they've done. They did a lot of the design work and the engineering work for you, so you just utilize what they've done. You have to be careful of you don't violate any patents or anything along those lines, but in the case of a trailer, that shouldn't be a problem. From there, once you have kind of what they've done, you have an opportunity to tweak the design or modify it, add some things maybe that work better for what you need. And that's one advantage of building something versus buying it, is you get that flexibility of building exactly what you want. As an example, I built a log splitter a number of years ago, and some of the features I wanted, no one actually even incorporated those, or one brand might have one of the features I wanted, but not all of them, and a different brand might have some of the features, and so it was easier just to build one from scratch with all of the different features that I wanted. As far as the design, laying it out, over the years I've done lots of design and layout with simply a pencil and paper. Sometimes that expanded out to being in the shop and a full-scale layout with chalk lines on the shop floor or string lines on the shop floor to help you kind of see how things are going to lay out, where they're going to land, what dimensions are going to be. And there certainly isn't anything at all wrong with that method, and it still works today. However, now that CAD has become much more commonplace, design and layout has become much easier and more precise. So for myself, even if I'm designing something small and simple, I'll still design it in a CAD environment first. I find in the long run I end up with a better end result, less mistakes, much more precise bill of materials, things along those lines. Some of you might be saying to yourself, I don't know how to use CAD, I don't know anything about it. Well, let me tell you, I was in the same boat, but that didn't stop me. I found some CAD software that I was happy with, was very inexpensive, and I simply taught myself. There's lots of online tutorials. Specifically this product that I chose, they had a lot of videos on YouTube of how to use their exact product, and the learning curve was a little steep at the beginning, but it didn't take long to catch on, and now I'm proficient at 2D design. I have started experimenting a little with 3D, but in the case of a trailer, or anything for that matter, you can do it in 2D. You may have to have different views and things along those lines. So without further ado, we'll just jump right into taking a look at the trailer in CAD. I want you guys to be able to see what I'm working with and how my design work went, and then we'll eventually make it out to the shop. Don't know if that'll be in this episode, depends on how long it is. If not, the next episode will certainly. We'll be out in the shop and start looking at the layout of the steel itself. Alright, so you can see the basic layout here. I'll do some various zooming in and out to let you see a little bit more detail, and so at first you probably can't make out a whole lot from this broader view, but it does give you a depiction, a top view here, and a side view. You can see where the axles will be placed. You can see that because the tires and wheels protrude above the deck, that it is a drop axle design, which keeps the overall trailer lower, a little bit better for trailers that you plan on hauling, let's say a car or a tractor or something on, versus a deck over trailer that would have the deck would be up here above the tires and wheels. Better for loading equipment from the side and things like that, but it also doesn't accommodate loading vehicles, cars, things that have low ground clearance very well. So so basically the purpose of this design was to give me dimensions, so when I could work out my bill of materials, it lets you see where things will lay in relation to others or lie in relation to others. In the case of the axles, the spacing, where I was going to put the axles is dependent upon what you want the balance to be and how many pounds of weight you want on the tongue. I'll touch on that in a minute. So it wasn't to necessarily have a fancy drawing that you could spin in a 3D axis. It was basically just to provide me the dimensions needed, and I can come back and reference the drawing so I know exactly where cross members are going to be, things like that. One item that does come in really handy with CAD, and which I incorporated here, I'll show you here, is the dovetail design. I'll zoom in here. The dovetail design is I wanted and as you can see here, the ramps allow for the trailer deck plane to be extended. So even though this dovetail here in the black line, or the black area, is 3 feet, I didn't want to lose that 3 feet of trailer deck, so there's 17 feet of fixed deck here. But when the ramps are folded, that happens to be, this triangular shape happens to be the same as the angle that this dovetail is dropped down, therefore filling in that void. So I'll give you an example of what it looks like when the ramps are folded down. And without CAD, you could certainly do this out on the shop floor. You could take some measurements and swing some arcs with, as I mentioned, chalk lines and things, but in CAD it makes it so much easier because you can make changes. So if I take this ramp, and basically this would be the same as if you're folding the ramp down manually. We bring that down where we're just touching the ground. That gives you a nice approach angle for a vehicle, again, that maybe has low ground clearance. But then when that ramp is folded back up, it creates that same plane of the deck to give me a full 20 feet. So that's something that CAD software lets you do those things quite easily. That would be a little bit more difficult without it. Obviously you can make changes on the fly, versus if you start cutting metal and welding things together and you're like, oh, that isn't quite right. You can kind of proof out concept in CAD design. So basically you can see here from the top view, just give you a little bit of an idea what the trailer design is going to be. You can see these boxes here. Those are the stake pockets. So there's quite a few stake pockets. The stake pockets are tied together. This area here that I highlighted, that's a rub rail. So that ties the stake pockets together and gives you additional places to hook tie downs to if a stake pocket isn't a convenient spot. It's not drawn in here, but I'll probably incorporate some receiver sockets up here at the front for a quick detach winch mount. That way if you needed to pull a stranded vehicle onto the trailer, I'll be able to do that. Let's see what else. If anyone's ever hauled something fairly heavy, let's say in a trailer like this, you wanted to haul a mini excavator or something. I've seen more than one case where a lot of trailers have those pull-out ramps that are stored. Those ramps, they'll slide into there's not a dovetail, but those ramps would slide in here. And so when those ramps are on here, for instance, if I just really quickly drew a line here, so if you had a ramp that went from the trailer deck down to the ground without any support, when you run that excavator up that, it will in turn push down on the back of the trailer, and I've seen pickups, the rear axle of pickups lifted off the ground because of that, the trunnion or the center pivot of the springs acting as a hinge point. So to combat that, there's two basic ways that gets combated. One, and this somewhat simulates it. If you have this portion of the ramp right here, you could call that a drop leg. If that has a drop leg that happens to come all the way down to the ground and touch the ground, then as you load things up here, that contacts the ground, keeps the back of the trailer from tilting down. That's one method to combat trailer tilting. The other method is fairly common, and I think it was actually shown in the picture of the trailer I showed earlier, is to have some form of a mechanical drop leg or a jack here at the back. Usually people use a tongue jack, that's sometimes the folding style, so you can fold them up, and then where you can bring that jack down and contact the ground, that accomplishes the same thing. Both methods have pros and cons. I haven't decided for sure. I think I'm probably going to go with tongue jacks, because if I use the drop leg, I originally had a design where this portion of the, right in here, this portion of the ramp had square tubing with another sliding piece of square tubing, a couple pins, so you could drop that leg down, make it contact the ground, but that distance changes depending on terrain, depends on how much weight you put on there. So again, I think I'll make a decision when I get to that point that I have to make a decision, but I'm probably going to use folding tongue jacks for that. We'll put that back. This will be a wood decked trailer, standard 2x lumber to probably 2x6s. If it was going to be a much heavier trailer, say a 12 or a 14 or 16,000 pound, I probably would have went with heavier lumber, but given it's only a 10,400 pound capacity, dimensional lumber will work fine. The main frames will be, pretty much everything in it is C-channel, so the main frames, I'll go up here to just to quickly gives you an idea of the cross sections. So the main frames are going to be 6-inch channel that's 8.2 pound. If you aren't familiar with how channel is measured or rated, it's the dimension of the height of the web by how many pounds 1 foot of the C-channel weighs. So this particular 6-inch, you can get 6-inch channel in many different ways. This particular channel that I'll be using is 8.2 pounds per foot. Has just a shy of a 2-inch flange on it, so that'll be the main frames. And the cross members, the tongue will be a 5-inch 6.7 C-channel, and then the cross members are 3-inch by 3.5 pound. The deck will be all wood, but the dovetail itself, that will be, from a traction perspective, if it's slick and wet, or I have snow in my neck of the woods, if you've ever been on a trailer with a wood deck and it's wet or snow on it, it's super slick. So the angled portion of the dovetail, as well as the ramps, that will, as you can see kind of here in the depiction, that will be expanded metal, not the flat stuff, the stuff where it's up on edge that gives you a sharp edge for tires and things to grip onto. There'll be steel fenders. They're not drive over fenders. Some trailers will, if they're a drop axle, they'll incorporate the trailer deck might actually come out into this area and fill this in, so you have a little bit wider trailers, and then the axles, or the fenders, are stout enough that you can drive over them if you had really wide equipment. But I'm not going to do that in this one. I want to try to keep the weight down. So most a standard pickup or a car will fit within the width of the axle, so you can put a pickup or a car on here. be a traditional ball coupler, 2 5/16 ball, manual trailer, tongue jack. That kind of gives you, I guess, an idea of what the trailer is going to look like in at least the CAD world. So the next step is going to be, we'll get you out in the shop and I'll show you my layout and how I'm going to go about my initial setup, and we'll start cutting some steel. So I hope that you stick around and come back and visit me for the next several episodes. And
all right, so we're going to walk out to the shop since there was enough time left in that first video. But while we walk out there, I thought I'd show you one of the projects I did, as you know, mention the log splitter as an example. So I'll take you out there and show you how that project went before we walked out to the shop. Sorry for the sun in the background. So there's a splitter built from scratch. Has quite a few features that many bought log splitters don't have. It has a feed ramp, so instead of having to stop and pick up one log at a time, split it, pick up another log, you can load about 8 or 9 logs on the loading ramp and then split those, saves back and forth to the ground. So one other project is a really good example of build it or buy it and how much money you can save is in regard to my shop. When I decided to build a shop, I went and got a couple estimates from some of the local builders for a pole building, and about had a heart attack when they gave me the quote. Felt it was completely out of line. Part of it had to do with the fact that there was kind of a building boom at the time, and so they were able to quote whatever they wanted and could afford to turn away customers. So I decided to pull the trigger and build it myself. But instead of a kit and a pole building, I decided to go with a traditional foundation stick frame, just like you'd build a house. I did do a ICF, which is an insulated concrete form, footing and foundation. So the concrete wall that the building sits on is surrounded in or poured within styrofoam blocks that give you a much better R value. So other than when I poured those ICFs, I had a couple of guys from work come and help me. Thanks to them for doing that, because it was a little bit tricky to try to run the hose on the pumper truck and keep on top of everything else. So 3 of us poured that foundation that day, 4 of us actually. And then I outsourced the floor, the slab itself. But other than that, every stick, every piece of paint, every roofing shingle, the whole 9 yards, I put up myself. There was a couple times I'd have my wife or kids come out and help with tip a wall up or things like that. But so I'll pan around here so you can see the shop. But it's a really good example of what you can build if you put your mind to it, and you can save a huge amount of money. I probably saved close to $30,000 by building it myself. It's a 32 by 44 building with a 16-foot lean-to on the long axis, fully insulated, wall, ceiling, foundation, heated, so I can go out there and work in the wintertime. So let's go in here and we'll take a look at the trailer setup. All right, so the setup on the trailer, many times as I was younger, I'd build things on the floor. That works, but you know, then you're crawling around on your hands and knees. You can't, it's not as easy to reach things. So I grabbed an older trailer I had that's just it's not even licensed for use on the road, but it's really well built. It's an old surplus military trailer that's 8 foot wide, 12 foot long. So it makes a really good working platform for things like this. So I'm going to build the new trailer, the 20-foot trailer, on this trailer as a platform. So I've got it here in the shop. I've got a couple of the pieces, the main frame's laid out. I got quite a few cross members cut. So some of you might say, well, how's that going to work when that trailer's moving around? And obviously it wouldn't work well. So similar to what you would see on an RV, they are there. I have 4 adjustable jacks set up. There's a picture of one of them. So that way I was able to get the trailer perfectly level, and it stabilizes it to where nothing moves around. So so that's the kind of the layout, how that's going to go. Down here we've got the axles, we've got those rolled inside. They were outside for a little while. And those are 5,200 pound each, rating with brakes. Part of the reason why I went, as I mentioned, with 5,200 pound axles is that overall maintenance costs, tires and those things later on are less money than a Load Range E 8-lug wheel and tire combination. So I'll set you up over here on the tripod, and the first thing I'm going to do is I want to make a little bit of room on the trailer. Back over here. The tongue itself is still at full length. That's the piece sitting out there on the roller stand. It's still at 20 feet, and so I need to cut that in half. So I'm going to get you set up on the tripod so you can get a bird's eye view, and we'll get started on that here in a second. All right, so I got you set up on a tripod here. One end of the tongue needs to have a 45-degree cut on it. So, yeah, you might be able to see the chalk line here, or the pencil line here. So a person could cut a 45. If you mark the middle of this beam, which I did, you could cut a 45 here on one side of it, and then turn around and cut another 45, but you'll lose a little bit of material. So since you basically can, this channel, there's a left hand and a right hand tongue piece, I can actually cut the 45 with the angle cutting right across the middle of the beam, and then when you flip the one piece end for end, the angles are both on the correct side, and you maximize your piece of material and you don't lose a little bit of material. So I've got the center line. This channel is a little over 20 feet 2 inches long, give or take. I think a quarter inch or so. So basically, I'm just going to lay out. I've already got the center line for the length, so this is going to be the center line of the width of the channel. And then now we can just put a 45 through it based on the 45 dissecting that both center points. So that's that cut line. I'm just going to extend that cut line down each side. And that gives me a cut point. I've got it supported on the trailer on one end, and then on two stands on the other end. So when I make the final cut, nothing's going to fall or drop down. So I'm going to roll the plasma. I think I'm going to use the plasma cutter. I could do it with the big cutoff wheel. I don't put it in the saw just because a 20-foot piece of this channel, like I said, it's 8 pounds, a little over 8 pounds per foot. So that's 160 some pounds. So by myself, that's clearly way too heavy for me to be trying to manhandle over into the saw. So I'm going to do it with a plasma cutter. But you could do it with a cutoff wheel. As I mentioned real early, you could, if you didn't have a lot of tools, you could even do it with a hacksaw. It might take a little while. Actually, I forgot to turn the compressor on when I came out, so I'm going to go do that. So that's going to give it a lot of background noise. I'll mute that out when I edit the video. So stand by here for a minute. All right, so we're back. The compressor finished filling up. My plasma cutter has the offset on between the tungsten and the drag tip is 5/8 of an inch. I used to freehand a lot of stuff, but I'm not quite as smooth as I used to be. So I typically lay out a straight edge to run the plasma cutter on, and that's a 5/8 of an inch offset between the drag tip and the center itself. So I'm going to lay that out here real quick, so that I have the offset for that. Just use a piece of square tubing on that line.
Okay. I'm gonna make the cut now. I need to get a lens for the camera so you guys maybe could get a better view of this. I'll see, I'll pause it here real quick and see if I can rig up something, a little bit of pair of goggles or something over the camera so you can get a little bit better view, so stand by. All right, I found an old welding lens and taped that on the camera, so we'll see how that works out. The plasma's gonna plug in here. I will freehand the sides, it's just easier because it's such a short cut. Alright, we'll take the lens off. Get you a little bit closer view there of the cut, how clean it is. The corners are a little tricky with going through that webbed portion. A little bit of hanging on there. Just down at the other end, working it. Breaking that last little bit loose. And then we'll clean it up with the grinder. So there's the cut for the tongue. I'm gonna flip this other piece up on the trailer so that I can work on both of them. They're not on the roller stands. Okay, so I'm going to grab a grinder here, and 4.5 inch grinder, and we'll get this cleaned up.
And then we'll probably use that as a good stopping spot for the first video, and then the next video we'll get into squaring up the main frame. Actually, need to cut the main frame rails to exact lengths yet, and then we'll get some PPE on. That takes care of that. As you can see here, using the straight edge on the plasma cutter gives you a really nice straight line as compared to there on the end. It's because it was a square cut there, versus trying to freehand it. At least if I was freehanded, it would be nowhere near that straight. So I might not have been real clear when I was talked about dividing the C channel in exact half, for because the ankle angles were opposite when it was switched around. What I meant by that was each end of the tongue has a 45 on it to just make it look nicer. So when I made this cut through the center point, the one piece gets flipped around so that compounding angle works well on the other end. And then so anyway, that's what that meant. Not that you could invert it. If it was square tubing, you could do that, but with channel, it would be, there's actually a left hand and a right hand. So I think that maybe wraps it up for this first episode. I got some other chores I need to get done today. So we will bring you back the next episode. Like I mentioned, I've got to cut 45s on the main, cut the main frames to length, cut some 45 miters off of just the, I'll just be cutting 45 just on the flange itself, not the web, and then I will get those cut to the width length, and we'll start clamping them down on the deck and get everything leveled out. So till the next episode, I hope to see you back. Thank you.